So, ladies and gentlemen, full room today. Excellent. Great meeting today. Today is a very, very special edition of the EPIC Online Technology Meetings. We have a fantastic agenda, but even better, we have a great group of people that I haven't seen for a long time. Hi, Gert from Juniper. It's good to see you. You look fantastic. Hi, John from EPIC or EPIC Consultant. Thomas, everybody's here. Why don't we start? Anna, are you ready? She looks ready. I think she looks ready. Let's start. Ladies and gentlemen, welcome. Welcome to the EPIC Online Technology Meeting on Photonics Beyond 400G. This is our number 20 of the EPIC Online Technology Meetings. We have covered many technologies so far, from LiDAR all the way to microwave photonics, from space all the way to in vivo imaging. We are dealing today with the next stage on photonics development for data communication. And we cannot do this with better people. I'm extremely happy today, as you can notice. This is not me, this is just the happy me. So I just have something to tell you, which is very important, which is that EPIC keeps growing. We are now 558 members, and our members are here, and we work for our members. Everything I do, every little finger that Anna moves is for the benefit of these 555 people. What they want to do is to make sure that today they understand the needs from the key companies in datacom sector. We organize lots of meetings, presence, and also organize online meetings. When the whole world goes back to normal, when the COVID-19 thing is something that we will tell our grandchildren, then we organize these present meetings. In September already, we have a World Quantum Photonics Technology Summit in Glasgow, and I want to have the EPIC meeting on photonics for beyond 400G at Microsoft. It was going to be last month. I want to have this as soon as possible. When the whole situation goes back to normal, you will receive an email from EPIC inviting you to the best meeting at the best possible location next year in Seattle at Microsoft. All of you, most of you are EPIC members. You know that you have a long list of market reports available. So I would like to encourage, because I know we have a big audience today, I would like to remind you, go to the extranet and download all these market reports. Carlos counted all of them. We have 17,000 market reports, data charts, view graphs. Just get it all because it's all for you. We bought it for you. And also one more thing, we have now the biggest website to find a job in photonics, www.jobsinphotonics.com. So actively, we proactively scouted the job openings of all our members, and we post them in the website. And now we're giving this website to recruiters worldwide to make sure that we get the best talent for the EPIC members. So if you're looking for a job, or if you have job openings, check this website or contact us. So we post the job openings in the website. And that's all I have to say, because now is Photonics Beyond 400G. What a day. I first would like to acknowledge our sponsors today. We have 3 fantastic companies sponsoring this event. Ficontec. Ficontec is the company, the machine system manufacturer who has positioned itself in the center of the manufacturing of photonic integrated circuits and any assembly based on active alignment. They are very well positioned at this moment on the market of transceivers, and they are going to continue that positioning in the 200, 400, 800, 1.6 tera. You will see. Great company to work with. Axetris, the manufacturing of micro-optics at wafer level has become real on many markets. The next stage is co-packaged optics, and these guys know what to do, know how to manufacture the best optics at wafer level. And Ligentec, silicon nitride photonic integrated circuits, a foundry service that can provide any requirement needed. But what is more important, they have DWDM solutions based on a right waveguide ratings, because of the low losses can actually enable this kind of manufacturing at wafer level. So I want to make sure that I acknowledge these 3 companies at the level they deserve. And as I already said many times in LinkedIn, nobody can do anything alone anymore. So I also would like to acknowledge the cooperations that we have with the COBO Alliance, the Ethernet Alliance. You're going to hear a lot about them in the next minutes of the meeting. And now I would like to give the floor to the smartest person in every room, Ana Gonzalez, R&D Manager at EPIC. What's in the menu today?
Yes, well, thank you, Jose, for this nice introduction. I really don't have words to say how excited I am today in front of this list of speakers and this list of companies. So yes, you can see here we have excellent speakers today, but if you go to the next slide. Yes, now you can see the entire supply chain that we have. So the goal of this meeting is to establish new collaboration, to find ways for all these companies to work together. And for this, what I would like to start with this super busy slide, with the associations that have been collaborating with us. So thank you very much, the Consortium for Onboard Optics, to the Ethernet Alliance, and to the Optical Internet Networking Forum for helping us to put all these list of end users together. So we have this vertically integrated networking solutions, where the companies that are working in these vertical integrated networking solutions, such as Microsoft, Molex, Credo. So they are going to tell us what are their needs, their challenges. So we have here the entire supply chain in photonics to help them. So what they need, of course, they are going to need cables and specialty fibers and connectors. For this, we have the companies, the key companies in this field, but also we have our companies that are making transceivers, such as Cisco or HGTech. Also the companies doing materials, wafers, WDM solutions, but also we will need laser, right? So for this, we have companies manufacturing VCSELs or semiconductor lasers. We can also have companies to analyze the market, and also for well, trying to simulate, doing the best softwares. Then my favorite section, photonic integrated circuits. Here we have, I mean, this is amazing how many companies we have here to help our end users to make new solutions using photonic integrated circuits. So we have the silicon photonics, we have indium phosphide, we have design houses, we have polymer photonic, silicon nitride, and finally the packaging, assembly and testing. So again, the entire supply chain for packaging transceivers of other devices. Also, I would like to thank and to highlight the work of the pilot lines in photonics that we have here represented. So we have a JPICs pilot line for indium phosphide manufacturing, going to large volumes of indium phosphide chips. Also, we have a PICSA for the packaging and assembly of these chips, and the pilot line Fabulous for micro optics. So that's it. And now I would like to give the word to John D'Ambrosia, who is a very valuable EPIC collaborator and EPIC advisor, to present this super nice slide. So John, yes, you have to mute yourself. Yes. No.
Okay, can you hear me now? Okay, so everybody, you know, we're going to be talking about beyond 400 gig, but before we have that discussion, we might want to say, is there a need? And the IEEE 802.3 Ethernet Working Group, shortly after the completion of the 400 gig spec, began work on development of a Ethernet bandwidth assessment to see what was happening in terms of bandwidth trends. That report was recently completed, and this is an excerpt from that report that shows a lot of the data that we had in terms of networking traffic. And what you see is a whole bunch of things here where the traffic has been normalized back to 2017. And you can see that there's a variation in growth rates anywhere from 2.3 to 55.7 times the traffic of 2017. It's just an absolute incredible number as traffic continues to grow. And as I always say, we need to always consider the exponential. And I think this chart is a great one to illustrate that. Now, if we were to consider just for a second what happens, and Jose, if you could click the button, please. We have 400 that was completed, as I said, at the end of 2017. If we were to start a new project today, it'd probably take approximately 5 years. Not knowing what the speed is, but if we were to consider that, you could click the button again, Jose. 800 would only be a 2x leap over what's happening, what was provided in 2017. And one more time, Jose, 1.6 would be a 4x leap. So if we were to compare these changes, one more time, Jose, you can see that 800 and 1.6, these steps, they're not exactly growing as fast as we would like with the rest of the traffic. And it's one of those things that we're going to need to consider. soon. The longer we wait, the longer these growth curves will continue to grow, and the longer, the more pressure that will actually build on us to have to come up with a solution. So as we start thinking about beyond 400 gig, we're going to need to think about where are we going and a time frame perspective. So please keep it in mind. I think when I look at this data, it's very clear that beyond 400 gig, the time is now to start these discussions. And with that, I'll turn it back over to my compatriots.
Thank you very much, John. No more times, Jose. I really like one more time, Jose, as your tag phrase. Also, I'm really happy that the hairdressers are back on. Apparently, you look fantastic. You look sharp. Epic is extremely lucky of counting with such a Epic advisors as John and Ambrosia and many others. John is really guiding Epic towards the next stage. I would like to say two more things, ultra fast photonics quickly. The first one, once again, thank you very much to the sponsors, Ficontec, Axetris, Ligentec, you rock. The second one, we are broadcasting this meeting live in YouTube. So I would like to say hello to all the YouTubers. If you want to contact any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, jose.pozo@epic-asoc.com. Send me an email and I will introduce you. That's what I do for a living, introduce people and make them work. And with this, why don't we start the meeting with the people who have really a lot to say today. And the first speaker is a person who really has helped Epic a lot. Is the person that I met for the first time when I found out about what COBO was and one exhibition, and I said, we need to work together. We have very similar challenges. And Brad thought it was a good idea. And now we are in this together. Brad, thank you very much for being here with us all the way from Seattle. The floor and the attention of everyone is yours.
Morning, Jose. Good morning, everyone. Welcome to the West Coast. We're not having one of our better weather days, but it's not bad out here. Shame that we couldn't actually bring you guys out at the end of April to experience Seattle and see the Microsoft facility and the construction that's going on at the Microsoft facility. But I wanted to welcome everyone to participate, and I'm glad we were able to pull off this meeting online. I think it's actually kind of symbolic in a sense of what we're going through today in our industry, all this change. This is all being part of driving the next generation of bandwidth and everything else that we're doing. For those that may be aware, we saw in certain areas of Microsoft's network a 700% increase in bandwidth on our Microsoft Teams, for example. It's just this new norm for us that everyone's beginning to experience is only helping to be driven by the fact that we built the technology behind that allows us to do this. And I think this is really important as we look forward. While we're experiencing change, I think our industry is also experiencing change. We're seeing a transition from what we traditionally thought was viable optical interfaces to how do we bring those optics down in power? How do we integrate that into on-die or on-chip or whatever form you want to call it? And I think that's a very telling feature. And I look forward to seeing what our presenters are able to show to you today. And I look forward to any questions people have on what we're doing moving forward. Thank you.
Thank you very, very much. It has been fantastic to have you today. You know the supply chain that we have in front of you. We have companies to do photonic integrated circuits, companies who are very worried about where the onboard optics is going, companies who are thinking whether to go coherent or not. If you had to give 2 or 3 questions that you expect to have answered after this meeting, what would be those?
Well, I think the thing that's kind of interesting to me is not so much where the supply chain goes. It's how do we align to an ecosystem. COBO's a fairly easy step from a faceplate pluggable optics. It's understandable. It doesn't really change the operating model that much other than moving the optics inside and potentially offering power savings, which is huge. When we looked at building Microsoft data centers right now, we look at doing 400 gig, the power requirements for a 400 gig ecosystem are actually quite high. It actually prevents us from doing some of that growth that John was showing on those curves. So, you know, we have to figure out how to bring the power down in these systems. And what will be interesting as we head towards doing things like co-packaging optics or eventually maybe on-die optics, how do we bring the power down, but how do we create an ecosystem that's healthy for everyone? And I think this is where the members of Epic COBO, EA, OIF all have to work together to collaborate, because we have to come up with some level of commonality to create a healthy ecosystem for people to be able to build and construct these components.
Before we start a panel discussion on that, which is going to be spectacular, I'm going to go to our next vertically integrated supplier today, well, vertically integrated solution provider today, the giant of this industry, Cisco. Gary, thank you very much for being with us today. We are really looking forward to hear what Cisco has to tell the rest of the supply chain to solve the next stage beyond 400G challenge. The floor and the attention of everyone is yours.
Thank you, Jose. So let me just share my screen here. In the slideshow. Okay, are you able to see that?
Crystal clear.
Yeah, okay, great. Hey, thanks, Jose. And yes, my name's Gary Nicholl from Cisco Systems. I am on the East Coast up here in Ottawa, Canada, where the snow is just about melted and it looks like it's warming up for the weekend. So I'm also the OIF board member, and actually on the call today, Jose, I'm actually wearing my OIF hat and also very nice OIF shirt. So I'm actually speaking really today to give you a quick overview of the OIF activities in beyond 100 gig. So again, I'm speaking today more from an OIF perspective and not so much from a Cisco perspective. All right, so I just got a few slides just to give you a bit of an overview of what the OIF is and you know, some of the activities we're doing in driving the industry or leading industry beyond 400 gig. So the OIF has been around for over like 20 years now. As it happens, I started Cisco late 97, and one of the first things I got involved with was the OIF when it was first founded. And at that time, we were working on high-speed interfaces off routers. You know, we were doing, I think it was 2.4 gig or OC48 at the time, and we were trying to connect those routers directly over optical transport networks. And we found at the time that the two worlds at the time, the datacom world and the optical transport world, were two very different worlds. They didn't talk to each other. And that's really was what founded the OIF, to sort of bring those two worlds together and address how to sort of really come up with some interoperable solutions for connecting high-speed routers at the time to optical networks. And the OIF has moved on since then. We've now got over 100 plus members. And one of the things I like about I think it's maybe unique about the OIF is we have a very broad representative of the industry ecosystem, all the way from network operating users down to testing and software component vendors. So, you know, one thing I like at the OIF meetings is we get some really good discussions, you know, across the full spectrum of the industry. Okay, so a couple of slides. The first slide, just trying to look at some of the, give you a feel for some of the OIF projects that are going on today that really are focused at enabling 400 gig, which is just starting to be rolled out in the network today. And a lot of these projects are actually, I think, the building blocks or stepping stones for how we move beyond 400 gig, which I'll talk about in the next slide. So in this slide, some of the key projects we're doing, there's first one is called CI, or Common Electrical Interface, 112 gig. So those are a range of 112 gig electrical interfaces. That sort of tends to be the bread and butter of the OIF, and we've been doing this right from the very beginning. We've always tended to be at the forefront of driving the next generation of sort of silicon or SerDes interfaces for the next generation products, and that started at 10 gig, 25 gig, 50 gig PAM4. These set are based on 100 gig PAM4 electrical, and we'll be moving beyond that, which I'll mention on the next slide. So again, it's been going, probably all started around the 2017, 2018, so it's well on its way towards completion. We have 5 channel projects, so we're going from very short interfaces like 25 millimeters, and that was probably the first for this project. We're really targeting some of the die-to-die optics, maybe some of that stuff that Brad was talking about, or some of the co-packaged optics we'll hear about on this call. We'll use those interfaces right up to 2 meters, like copper cables for equipment or over backplane. And really, this project is a sort of key enabler for, you know, as the industry moves to higher capacity switch chips, say like a 50 terabit switch chip, where you need to go to really 100 gig IO on the chip interface. So this will be a key technology for that. And it's also really a key technology for enabling 800 gig pluggable modules. We'll talk a little about that later. So again, today a lot of the 400 gig pluggable modules are based on 8 bielectrical interfaces. And this project basically takes that electrical lane rate up to 100 gig, and therefore is really a fundamental building block as we move to higher capacity pluggable modules. The second project I just want to mention, this is it's called 400ZR. It started back in sort of late 2016. That's actually a 400 gig coherent DWDM solution, targeting like shorter reaches, and really optimized to try and fit that technology into client interfaces in a very small form factor and low power dissipation. To me, this is another one it's a very interesting project because this is sort of OIF almost going back to the roots when we started 20 years ago, because this was really identifying a gap in the network or in the industry and some of the standards bodies. And it was taking essentially a coherent technology, which was really started off probably mid-2000s, focused more in the telecom space, driving very long distances, like 2,000-3,000 kilometers, all based about sort of high performance. It was all about, it tended to be more like custom proprietary solutions because a lot of the vendors were really trying to eke out the last half a dB on the link budgets. He was trying to take that technology and move it, recognizing that a lot of the customers now wanting that same technology, but really for a different application space, much shorter reach, really wanted to get the POS down, wanted to get into a small pluggable form factor, maybe the same form factor that they would use for their datacom switches, and really all about trying to drive a standardization, if you like, of that technology, drive a robust wide ecosystem, really all about driving up the volumes of that technology and therefore driving down the cost, which is important for those users. And again, this is a solution that's really more Ethernet optimized and trying to take that traditional long haul telecom optical technology and drive it into a more Ethernet optimized high volume, low cost application. Another project is something called the IC-TROSA, that stands for Transmit Optical Subassembly Component. Again, that's more a component level project. And that's the sort of fundamental optical component that you'll find in any sort of coherent optical module. Again, the goal there, as we've done before, was to try and take that technology, define a form factor, and somewhat drive a broad industry ecosystem around that component, again, to drive up the volume and drive down the cost. And again, that's a key enabler for the 400ZR I mentioned above. And the last one is something called CCMIS, or Coherent Common Management Interface Specification. Again, it just points to the broad range of things we get involved with at the OIF, from electrical interfaces to optics to components. And this one is actually a management interface specification. Again, in the industry, as we move to the 400 gig optics, we recognize that those optics were getting more and more complex. They all had like DSPs in it. And so we actually upgraded the management interface specification to those modules at 400 gig. And that was something called CMIS, or as I said, Common Management Interface Specification. And what we've been doing in the OIF is providing some extensions to that, really to support these next generation of sort of coherent optical interfaces. So again, if I just look at some of the things that the OIF is doing to sort of lead the industry, as we move beyond 400 gig, maybe looking a little bit further out, we had a very well attended 400 gig ZR workshop and industry survey. That was discussed in our February meeting in New Orleans. I think that was our last face-to-face meeting. And really there we got a lot of very good end user requirements into what do we want, what do they want to see as we move beyond 400 gig DWDM, and what are the requirements there. And that really led into sort of a work session that's ongoing at the minute called Next Generation Coherent. We had some discussion of that at our virtual May meeting last week. The goal there is really, okay, like what do we need to bring the concept? I think 400ZR as a project in the OIF has been very successful in sort of driving that technology in the direction it's needed for the industry. So how do we bring that concept and success, to higher data rates? Because it's clear that the industry will need something beyond 400 gig coherent, and that could either be higher data rates, higher baud rates. Maybe we want to look at longer reaches, or maybe actually as we go beyond 400 gig, we need to take some of that coherent technology, which is traditionally long haul, and maybe drive it even to even shorter reaches, maybe down in the 2 to 10 kilometer space as well. And we might hear more about that on this call. We're also kicking off like a co-packaged optics workshop in the summertime. That's something we haven't been directly involved with the OIF. As I mentioned earlier, we did some of the electrical interfaces that could be used for some of the sort of co-packaged optics solutions, but we're, clearly as we move to higher and higher speeds, it gets harder and harder to do pluggable optics. So there's a lot of interest, obviously, in the industry in co-packaged optics in minutes. I personally think it's not a matter of if, but when, and that I think that's still out. But we're definitely starting to do some work and look at that seriously. The other thing we've got going on is this thing called Beyond the 112 Gig Electrical Workshop. That was originally, we actually said it was a very interesting, very good group of presenters, and it was already scheduled for OSC, but unfortunately that got cancelled due to the coronavirus. So we've now moved that to an online webinar. I think it's happening in the June timeframe, so please feel free to sign up in that. I think we've got a very broad and a very interesting range of speakers, and again, looking for sort of the need and requirements for next generation electrical interconnects beyond the current CEI 1112 gig projects, and sort of looking at that. And sort of related to that, sorry, at our virtual meeting, which was just last week, and along those lines, we actually did kick off a project start proposal. It got approved to start, to start working on a project start proposal for later this year, looking at something we're calling CEI 224 gig. So again, those are really the project beyond the current CEI 112 gig, looking at data rates around 224 gigabits per second. And again, that clearly a bit more, is a bit further out, but really looking to enable, as John mentioned in one of his slides, if we want to get up to 1.6 terabit architectures and we really want to drive lower cost and complexity, even 400 gig and 800 gig solutions, that's a technology that's going to be very important. Because again, if we even driving down 400 gig and 800 gig cost, it's all about trying to drive the lane width, drawing up the lane speed, so to get us maybe into 4-lane optics modules for say 800 gig and that sort of thing. So yeah, that's just a very brief overview of some of the activities and some of the new projects that are kicking off in the OIF. Just the final bullet there is I think the OIF is we've already started the Beyond 100 gig work, and we've been actually some have been working on for a couple of years now. So I'd just like to reach out to everybody in the EPIC community, like please feel free to join us. OIF, like a lot of these organizations, are like contribution led, so things only happen if people get involved and participate. And I think as other people mentioned, I think as we move forward beyond 400 gig, I think we can all help each other here. And I think that I'll just throw up my OIF 20-year slide, but I think that's the end of my talk.
Okay, thank you very much, Gary. Very nice presentation. And I am sure now all the companies here want to join your association. But regarding the project, with your IOF hat.
Add-on, yes.
What are the companies that would you like to involve? What are the challenges in these projects in which you are working, so our companies can help you?
Yeah, and again, I think there's as we move beyond 100 gig, as a number of these people, and I've had a number of discussions with a number of people on the call or on today, I think things are just getting harder and harder across the board. And again, the OIF, we've got a very broad range of industry participation. And I think there's problems at all levels, like in terms of what are the end user requirements. There's a lot of input and constraints from the system vendors as we move to these higher and higher speeds, and we're trying to sort of get that technology into smaller and smaller form factors, and we're thermally constrained, on a lot of our platforms, and then right down to the sort of the component level as well, in terms of just getting that coherent technology into smaller form factors and driving to these higher speeds. Does that mean we have to go to 200 gig PAM4, or is there some other modulation formats we need to look at? And again, as I see John in the call, I know John and I have had lots of discussions about, as I mentioned, the coherent technology started off, in the very long haul space in the telecom market And we've managed to move it down into that 100-kilometer reach with this 400ZR project. I've got a personal view that, it's going to go, the gap is shrinking, and you might see some of that coherent technology actually move potentially even to some of the more traditionals, what you would call client interfaces for Ethernet and stuff. So I think there's lots of problems to solve going forward. So we're all going to be kept very busy.
Okay, thank you. Questions, comments for Gary? Okay, if not, well, you mentioned that one of the issues, well, Jose, I think you would like to add something.
I am enjoying the meeting so far, but I came here to have fun, and I'm going to have fun. So basically, we started with the presentation from Microsoft, and he said, I think the power consumption is a challenge. I see the presentation from Cisco already going into that direction, so I'm going to introduce them to some of my friends. My friends who can actually solve, or at least help solving that challenge. And I'm going to go to one of the companies who have in photonic integrated circuits on polymer photonics. We have an epic member called Lightwave Logic. Karen, how are you doing today?
Hey, Jose, good. Thank you. Thank you for this meeting.
Could you tell us a bit what is Lightwave Logic and the epic question? What can you do for them and what can they do for you?
Yeah, so I think a lot of the people on the call already know us. We're making polymer, electro-optic polymers. This is a material that is highly responsive to electric fields. So we think that, especially with the new material we just announced last week, we should be able to get very high speeds, 100 gigahertz, gigahertz, not gigabit, 100 gigahertz response in the couple of volts range of drive voltage. So what we'd like to do is to be able to relax some of the constraints that people see. So this is one of the things that we've come here to find out is, okay, if we say we we can increase the native speed of the modulator, say from what's classically 30 to 50 gigahertz up higher, does that change the discussion about modulation formats? Can we simplify the processing chips? If so, where would you like to see this? Where are you feeling that crunch the hardest? Is it clear that it should be coherent? Should it be shorter reach? I mean, one of the new things we announced last week is that we now have a material that works at 1.3 microns. So classically, polymers has been addressing the long haul area. That constraint is now gone. So, I'm here to ask, well, is it more interesting to work at 1.3, or is because of this trend that Gary just mentioned with coherent, hey, everything will go to 1.5?
I think we need to give the word to Gary now, because obviously everybody knows you are publishing the intention of Acacia's acquisition. Everybody's very aware of that. The future of Cisco seems to be towards coherence. What do you have to say to Karen?
Yeah, that's a sort of difficult question to answer. Is like, how long is a piece of string? Of those people that know me, in the past, I've been, as I said, doing this for like 30, 40 years now. I used to have a pretty good intuition of what the next thing to do was. I find that's getting harder and harder these days. I think, as we mentioned, as we move to beyond 400 gig, things are just getting harder. We're getting up some hard sort of physical constraints from a technology perspective, from a physics perspective, and so I think what that tends to drive is that then there's no clear, easy solution. Everything's quite difficult. You tend to get a lot more solutions on the table, and again, all of us in the sort of roles we do, it's harder and harder to pick and choose what the right solution is. So I think the short answer is I don't know. We're going to go beyond 400 gig.
Oh, that's clear.
Whether it's 800 gig or 1.6 terabit or something else, or all of the above,
Let me introduce you to a few other of my friends. So I'm going to go to a beautiful city in the Netherlands. It's called Eindhoven Rock City, but most people don't know the second part of the name. And I'm going to go to a company called Smart Photonics, because Smart Photonics has developed a platform for indium phosphide, and they are very confident that the epitaxial integration of all the components is really the best way to go for the power consumption and cost reduction. Luke is the CTO of Smart. Hey, Luke, how are you doing?
Yeah, thank you, Jose. I'm doing fine.
So
Thanks for organizing this event.
how do you feel the discussion is going? We are talking about coherence. We are talking about the challenges towards the next 800G. What does Smart Photonics have to say on this field?
Yeah, well, for us, we are a foundry making the indium phosphide, so we believe there's a certain cost advantage in combining a lot of the things. Therefore, we have to. You always have to make the trade-off, combining the best of both of multiple worlds. So if you have seen also the polymer modulators that have been addressed just briefly, and see where it is. We do not have a clear direction on what technology it is. We have a platform that can enable multiple different modulation formats. For instance, we have monolithic integration of both EAMs as well as MZIs. They all have their advantage. So some are better for longer distance, some for the shorter distance. But I think there's some tuning required. The basic technology to integrate multiple components is there. But we have demonstrated up to 6 parallel lanes without overheating, but yeah, it's a matter of having all the whole system architecture in place. I think that we can be a cost-effective part of that.
With discussion with many of you, actually bar discussions very late in the evenings at OFC, I really understood that the challenge seems to be on the modulation. And many of you told me, I think the one who can manage 100 gigabaud channel, the first, and is reliable and cost effective is going to be on the money. So I made some numbers there. I saw the modulators of indium phosphide from HGGenuine and Smart Photonics. I saw the modulators for lightweight logic. I saw what Nokia Bell Labs published in Plasmonics. I think we are getting there. Could you comment just a bit about the specs that you have in the modulation side from the building block of Smart Photonics?
Yeah, well, we have working together with our customers. We have demonstrated for EAMs up to above 60 gigahertz, and that has to be optimized for a specific application. That's fully integrated. And then you can put 4 channels next to each other, completely integrated. If you make some standalone modulators, they can be optimized for one or the other. And if you look to what has been demonstrated on MZIs, on phase modulators, that's even beyond that. That has not been demonstrated in our platform per se, but the basic technology is there to go up to 56 gigahertz for Maxino modulators. Actually, NTT has even demonstrated much higher, but that's not completely integrated.
Thank you. Well, look, you're going to like the next question, Gary. I have a question from the YouTube universe, from a company also in Eindhoven, far enough, a company called Effect Photonics. So Aaron Alvarez Mejia is wondering, is an OEF implementation agreement seen as the final standardization document? What is its implementation flexibility during product development?
Yeah, so again, so the OIF really defines these things called interoperation agreements. They're really more aimed at sort of product development. They tend to come early, and quite often you will see, and maybe other people on the call will talk about it, that the OIF does a lot of the initial work. We drive some interoperability agreements. If that's a clear direction that the technology is going in, we quite often, and we do liaise and see a lot of that initial technology being sort of picked up by other standards organizations like the IEEE, for example, and John knows this very well, and maybe driven into more of an IEEE standard.
Back to you, Anna.
Yes, okay, thank you, Gary. Question, more comments for Gary from the audience? Okay, good. So if not, let's go for the next speaker. So Jim Theodoras from HGGenuine, and also representing the Ethernet Alliance. Would you like to share your screen?
Yes, thank you.
Perfect. So, okay, if you go to presentation mode.
Okay, so just quickly, who we are. HGTech is a very large multi-billion-dollar company listed on the Shenzhen Stock Exchange under stock symbol 98. Now, within that large conglomerate, HGGenuine is the optical transceiver division within HGTech. So I like to kid or joke that HGGenuine is the largest optical company you've never heard of because it's not very well known, but they really carry a dominant position in PON transceivers within China for fiber to the home. And a few years ago, they decided, having reached market saturation, they wanted to grow. Well, what do you do if you want to grow? There's only two ways you can grow, and that is either go outside your geography or go into other market areas. And they decided to do both in moving into data center optics. So that was a few years ago. It went probably a little better than expected in that we have two large factories and they're currently at capacity. So we just opened early this year a brand new $100 million factory dedicated to 400 gig data center optics. So long story short, we're an optical transceiver manufacturer. So I wanted to briefly talk about what I call the rise of the optical engine. Now, everyone knows about the prior hype about indium phosphide PICs with companies like Infinera and others, and then more recently, wafer scale integration of integrated optics into silicon photonic wafers. And I don't mean to talk about any specific technology. For me, it's more of a business construct of an optical engine is any widget that contains all the really difficult optical technology or intellectual property so that the next higher level assembly you're building can have a lower threshold of difficulty and be the lower margin part. So, and at HG, we're completely technology agnostic. We use all of these that I've listed here. And in one particular product, we have three of those, two in the TOSA and one in the ROSA. So we're technology agnostic, but for me, it's more about the optical engine, not just the technology. And what's occurred, and I think some have realized and maybe some haven't, there's been a seismic shift in optical transceiver manufacturing in that the barrier to entry to making the physical transceiver has been lowered. My engineers that work for me hate when I kid that I could build this thing in my garage over the weekend, and I couldn't. But it's the transceiver itself has gotten easier because the tough stuff's moved into the optical engine. So the barrier to entry to making the optical engine has risen a lot and gotten that much more difficult. So I have one little picture there from PIC magazine because it was open source. This is the Alibaba's DR4 design, and everything is thrown into what they call the APE, Alibaba Photonics engine. So making that module is easy, making that APE is very hard. So why am I here speaking to EPIC today for HG? Well, for me, design for manufacturing is the difference between making and losing money on these transceivers because that optical engine has gotten so complicated. And at HGGenuine, the time between engineering verification testing and the final product verification testing, where you can do 500, 2,000 hours, can be 3 to 6 months long. And that's not because we're slow, it's because it's so critical to get the production volume and process mature enough that you can make money on a design. So it's no longer just about the BOM, it's about getting the throughput high enough that you can make money. And over the last few years, I've generated this graph you see on the left there in white that I call it the make or break graph, but what I've done is I've analyzed designs that went well and maybe designs that didn't go so well. And I can now pretty much predict ahead of time based on past experience in a math model, whether it makes sense to build a particular design. And the red, green, and blue lines there are whether it takes up a half production line, a whole, or a double. In the case of a double production line, one whole line for the optical engine, then one whole line for the transceiver. And if you get your run rate high enough, then the additional unit cost is low enough that it becomes producible. So you want to be in that yellow box there. You don't want to be up in the top far left because then doesn't really make sense to make that. So what does that have to do with beyond 400G? So 400G, we currently have lots of 400G products that are doing very well, but I'll admit they're really pushing the limits of what we can do with today's technology. And it's not, we could build anything, but DCOs have very aggressive price targets, $1 per gigabit per second. That's just kind of an average. If it's a short server drop, it's got to be maybe 10 cents per gigabit per second, and maybe a little bit more is allowed in the DCI transport. But it's really hard to hit that given today's complexity. So when I've been attending a lot of these sessions and I've seen these technologies of EPIC have great potential, given the breadth of technologies, to bring all that to bear on the optical engines, so that as we move beyond 400 gig to 800, 1.6 terabit per second, that it actually becomes doable. Because and as previous speakers have mentioned, everything is going to be needed to make this happen. And as Brad said earlier, we want a healthy ecosystem. So we're hoping that groups like the OIF will make optical engines standardized, and then all the technologies companies can join together and make these optical engines not only standardized, but feasible, producible, and then make the optical engines as easy to build as transceivers are today, because it's that whole situation that needs to be improved. And that's why we're talking today. Thank you.
Thank you very much for a great presentation. It is great to have HGTech with EPIC. And also I love the fact that you refer to the technologies at EPIC. Is your first ever EPIC speech. So I really want to give you the EPIC question. You have to get used to it. Everybody gets it. Is what can you do for them? What can they do for you?
Oh, what we can do for EPIC members, we can be a great test bed. So we have a lot of what I call technology partnerships. And that doesn't mean we sell things together. It doesn't mean we're all out to make a buck. We're looking at what can we do, and to see what can be done and what works and doesn't. You need to have partnerships where you try their technology on parts you're doing, and you just play in the lab and make things and see what worked, what didn't work, and get that fail fast and figure out, how do I get to that next level? Then you can take that information into the standardized meetings and say, here's what we found when we played with these technologies. This kind of worked, this kind of didn't. So we can be an important test bed for these companies to try out new ways of making our widgets smaller, more accurate, and more producible.
Okay, so let me find you partnerships, because that's what I do for a living. I'm going to go to a company in Switzerland, because Switzerland is a beautiful country in the mountains, and they do fantastic silicon nitride photonic integrated circuits. So you know the guys from Ligentec. Thomas
absolutely.
is here from us. Thomas, how are you doing today? Thomas, how are you? I think we have a problem with your sound system. You look fantastic with the headphones, but we can't hear you. Bottom left corner of the screen, you can select a different microphone. If not, I will come.
Can you hear me now?
Fantastic.
Okay, great.
Oh, there you go.
No, beautiful weather here. Great time. I enjoy the home office. We're doing silicon nitride, and a special kind of silicon nitride. It's a thick silicon nitride with a high confinement, and actually kind of combining the benefits of glass integrated photonics with the ones of silicon integrated photonics. And I would love to talk to you, Jim, and go deeper into the options, what we can do for you in the next generation transceiver modules.
Oh, yes, I would love to talk outline. We actually have two products that have silicon nitride on the ROSA side. So we definitely currently use that. We like it so much that one of our silicon photonic engines has a built-in receiver, and we don't use it because we prefer to come out to our own silicon nitride bench. So we'd love to talk to you about ways of partnering and looking at what can be done.
Fantastic. And I love introducing the companies to each other later, so I will make an introduction between the two of you. I'm going to find you another partner, because seeing the slides, I know the packaging is the challenge, and on that we excel with the EPIC technologies, as you refer to. So I'm going to go to Berlin, and I'm going to go to a company called Ficontec in Berlin. Herman, how are you doing today? Looking fantastic. I think I have you muted still, so please unmute yourself so we can hear you. Yes.
I'm doing very good. What about you?
Doing great. So happy today.
Sorry?
Yeah, doing very well. So what can you do for HGTech, and what can they do for you?
Well, I saw the points that actually the costs are a major factor. So what came to my mind is basically what we are talking about, the packaging OTM. This was active alignment versus passive alignment, and probably cutting the time using UV epoxy, probably remember that. So we would be open actually to help companies in this field figuring out how to produce such kind of new transceiver module in a let's put it this way, rather simple way, for example, using passive alignment and trying to shorten the curing time if possible.
That is excellent. I'm glad you brought that up because one of the shocking aspects to me was that to hit our price points, our throughput on the alignment machines have to be very high, and you can't hit that if you are hitting glue with UV light, even when we use the really fast stuff and you try to do multi-dimensional alignments all at once. So, and we prefer to do a spot weld with a CO2 laser because it speeds things up, but I would love to have discussions with you. Passive would be the ideal way to go because then you save that time completely. It's as you probably know, it's very difficult. And so we definitely are looking for experts to help us with this journey.
Jimmy, you ever want to have fun talking about active versus passive alignment? Join one of our packaging meetings. We've been talking until 5 in the morning with Ficontec, with Fintech, with Axetris, with Tehema. It's been super fun. I would like to give the floor now to John because John, you had a question before from a previous speaker, right?
It wasn't really a question as much as an observation, and it's been a theme that's been reiterated in parts by Brad's touched on stuff in terms of the ecosystem. Gary touched on it in terms of we don't know what the right solutions are going to be, and you touched on it by asking what can Epic members do. You know, Gary and I, as he said, we talk quite a bit, and we throw all these things out. And you know, Jose, you remember my first experience with Epic was I didn't realize all the different places where optical technologies were being used and being developed. And I think what's great about Epic in this meeting is having these open discussions, because what's going to need to happen is it's not going to be just about getting to a solution beyond 400 gig. It's not. It's going to be getting to a cost-effective solutions, because there's multiple markets and multiple solutions that are going to be needed at an attractive cost point. So when I talk to someone like Brad, and I've been doing this a lot recently, and I know Brad has made these sort of comments to me before, we can't lose sight of the cost, right? Because I know from dealing with people in that community, it's not enough to have a solution. You have to have the solution at the right cost, all right? And all these technologies that are coming up here, if they can contribute to the cost and driving the cost down, are effective, are useful, need to be understood, need to be known. If an alignment cost can reduce a manufacturing cost, that's great. But what else is there? We don't know. That's why everyone's here today. So, you know, I'm coming into this with a very open mind, with no preconceived notions. And Gary, you and I have had this talk. We don't know what the right solutions are. There are people who are saying, well, maybe it's discrete and it's, you know, direct text signaling and it's 4x200. Maybe it's 1x800. These are all great questions, but all of this cost we can't lose sight of. So, you know, thanks to Epic for bringing all this together. And I think, you know, Jose, people like Gary and myself, when we're thinking about all these things, I don't think we know all the answers at this point. Gary's kind of made that same comment. I think instead we're still trying to figure out what we don't know we don't know.
I think in this world right now, nobody knows. And the only way to find things out is to working together. And I love that part. I had two people raising the hand, and perhaps the biggest moment of the meeting is starting now, because Mark Lukovitz, what's in your head?
What's in my head? I'm not sure, but I wanted to ask Jim a question. I've known Jim since the Advent days. I consider him to be a true expert in technology. And I guess, Jim, you know, I ask softball questions all the time. It seems like in the States, there's been this push to go with non-Chinese vendors even before the virus breakout. And that's maybe why you've seen certain companies like Sumitomo. I don't know whether they ever got out, but they're looking maybe to stay in. And then you see Broadcom getting back into the space selectively. You have the added problem of being located in Wuhan. What's your view of the situation in terms of going forward?
Well, first to clarify, you called me an expert. As Gary said, this stuff is getting so complicated and so broad technology-wise. I don't think there's any experts anymore. That's why it's important we come together and share our knowledge as a community to try to make this really difficult stuff work, moving beyond 400 gig. But as far as the Chinese vendor base, it's a global economy, and as John DeBroja showed early on, the demand is outpacing, the bandwidth demand is outpacing the ability of the industry to respond. And so pretty much every transceiver that can be built is being built and is being pre-sold on allocation. So, and some of the subcomponents, even out of the VAR situation, are even further out on allocation. So I think for our industry to respond to this demand, this insatiable demand, it's going to take everybody across the globe making transceivers. So that's why I don't consider other companies that build transceivers my competitors. I consider them my colleagues and partners, because really there's too much business to go around. It's a problem the industry has. And that's why when I talk about design for manufacturability, I like to see when we get to whatever's beyond 400 gig, all of our groups and standards and MSAs focus a little bit more on not just the BOM and the technology, but also producibility, manufacturability, and maybe how do we build in some of this passive alignment and things so that we don't end up to where we just can't make enough stuff. And and CPO will help that, because you'll take a whole lot of discrete transceivers out of the equation. But yeah, I think there's more than enough business to go around.
That's why you feel so well at Epic, when you have this spirit to work with the so-called competitors. I have a question from Lightweight Logic, Karen.
Yeah, so I really liked what Jim said about it's not just about the BOM, but it's the whole manufacturing cycle. And you talked about alignment already. I wanted to just ask, what are you foreseeing coming up in the way of testing challenges, especially as electrical interfaces get really fast? We can see in our labs that these high-speed electrical things are really tough to deal with. We're wearing out our probes just on the 100 gig test sets. I mean, stuff becomes consumables and they're very expensive. At the same time, we're seeing interest in optical tests. Are you seeing optics come in for at the other end of the equation as well as we get up to these speeds?
Well, first, let me do a two-part answer if there's time. I'll try to be brief. But first, let me give an example of how the optical test time can be improved. So we had one part that was actually slightly losing money because of the test time. And it was because we were reading the optical power of the receiver multiple times, and each time we're reading it through the I²C of the module. The module reports optical power. Why wouldn't you use its own power? Well, when we come out of our ROSA, we actually split the signal into two parts, and one part of the signal goes to dummy pads, and we come down with springs on that pad and read it with a bench grade high-speed A to D that instantly reads it. And our read time went from hundreds of milliseconds to microseconds. You say, well, how could 300 milliseconds really be a big deal? Because when you're doing it multiple times and you have to make 1 million transceivers per month, every millisecond counts. So just doing that change brought that product from a money-losing product to a substantial money-making product by thinking ahead. And so those are the sorts of things where test impacts the alignment time and then how many you can make per week. But to answer your question about the difficulty in probing, fortunately, the DSP vendors and the various other chip vendors, they've done a good job of putting test features into their code. So if you have a good relationship with the FAE, they can actually enable some hidden test features that let you run a self-BERT and a BER, and they can actually put stressors onto your lines. So where we haven't been able to directly probe if our product is good or not, we've been able to take data out of the DSP, put it in MATLAB, do a reverse FFT to it, and say, oh, this is my S parameter, my impulse response of this chain. So kudos off to all the chip vendors out there who are building in the features we need that at the transceiver level to know our designs are good when it's impossible to probe some of these latest high-speed parts.
And kudos to HGTech openly to collaborate. Thank you very much, Jim. John's points were raised a lot of attention by Brad and Gary. Brad, what do you have to say to John?
Well, I think, actually what John is talking about and what Jim is talking about are both very relevant relative to building large scale data centers. When we go to at scale and when we start looking at this, one of the implications is not just the cost of the materials. It really is actually now becoming the cost of the power. So when we look at designing some of our next generation data centers, when we look at what we're trying to do with 400 gig and what we're looking at trying to do going beyond 400 gig, that power that we're starting to demand from these components is actually preventing us from growing our data centers to the scale that we would like. And what it's actually forcing us to do, which is not really what we want to do, is it's forcing us to build more data centers. So there's that trade-off there in these systems that we have to understand as an industry. If we just look at it as a material cost, that's nice when you want to build it and manufacture it. But if you're asking me to go from 100 gig to 400 gig and I've got to go 3x the power, that means I actually have to look at building new data centers. So, that's the trade-off that we don't want to walk into, because building new data centers is actually very expensive. We would like to be able to use our existing data centers as much as possible and grow within those. The other part that I think is interesting is when you start talking about manufacturability and reliability. Yeah. Imagine today that we go to an order of magnitude more optics in a data center than we do today. If we start driving optics to the server, or building AI with full optics systems, machine learning systems, once those optics are deployed, they are considered in production, which means I want to be able to see everything that Jim has to ask an FAE to go in and look at. I want to be able to see those because I need to know when I'm going to have a failure. I need to know the reliability of that link. I need to be able to see down into the minute detail, because I'm not doing small deployments where I can send a guy out and he unplugs and replugs the cable. I need someone that's sitting in a remote room, probably in Seattle or somewhere else, and can sit there and diagnose our system in Amsterdam and diagnose our systems in Singapore. And so that's the change that I think we also need to understand is, well, we have hidden a lot of that visibility into driving reliability. That actually, for hyperscalers, is becoming a very critical component to be able to have access to.
Gary.
Yeah, thanks, Jose. So I just wanted to follow up on something John, I guess Jim, and what Brad just said there as well. And maybe what does it mean in terms of the EPIC and the membership? So, as we said, like Brad and his fellow industry colleagues are driving this to, move to higher and higher speeds, but obviously at lower cost and also at lower power solutions. And as I said before, things are just getting more and more technically difficult. You either go faster baud rate, that drives you down a modulation approach. Maybe you have to go wide, that drives out some of the optical integration stories we've heard here. So there's different ways to skin the cat, and it's not clear what the right solution is. So all of those factors are driving us where there's a more diverse solution space that we have to choose from. And you could say in one aspect that makes it challenging for people like John, myself, and Gert, and maybe other people as to what's the right solution, and how do we pick the right technology. In the other aspect, that you could say it actually provides opportunity for a lot of the EPIC members, because I think now you may see some other technology, optical technology, other come out of the left field that maybe some of us are not aware of, and that's why I think these sort of things and the sort of stuff that EPIC's doing is useful, because I think it's probably more important going forward. You could argue maybe it has been in the past, because it's not clear what really the right solution is. And so I think it provides more opportunity for people working in this industry to come up with something that maybe people in the mainstream weren't aware of.
And I think many times we discuss what is the next step, and I think the next step is really to talk to each other. And there, Molex has been a company who really has set up the flag in the integration of electronics and photonics already from many years ago. The first time I met them, I was working with the EPICS Fab people talking about silicon photonics, and I got in love with this company. Thank you very, very much, Tom, for being with us today. The floor and attention of everyone is yours.
All right, is my screen up for everyone?
It's fantastic.
Awesome. Well, thank you for this opportunity to speak with you today, and thanks for joining. I'm going to be covering a couple of very simple high-level topics today, and I heard some themes. What do we know, and what do we need to learn? So I think we'll address those at a high level in terms of optical connectivity. I'm in the optical solutions group of Molex, and that group is consisting of optical interconnect, optoelectronics, where we're manufacturing the transceivers at all the different speeds and feeds, wavelength management, which is a broad category of optical components, all the way up through Raman and EDFA amplifiers and WS switches. And then we take all those components along with Molex's traditional high-speed electrical expertise and build the subsystems for our OEM customers, where we're putting all that expertise together, working in concert with our customers to deliver telecom solutions, data center applications, and working on what's coming up with 5G, and also applying some of those things to other industries such as the aerospace and medical industries. We joined COBO because we had a lot to bring to the on-card optics marketplace. We have been working with onboard optics for almost decades now in one of the premier systems that deployed these in the telecom space was the Cisco CRS-1. And over many generations of programs and working with customers, we have a set of products that support onboard optics, whether they're multi-mode or single mode, whether they're coming through the front panel or going through blind mating backplane interfaces, to solve these interconnect problems of how do you get from those faceplates to the onboard optical engine? How do you get around the components on the board? How do you do the fiber management? How do we help customers manage the thermals and the airflow and do the fiber connectivity with optical shuffles and trying to manage what they're doing with their physical connections? So these products are things that I would say the industry knows, right? We already know how to do this. They've been field deployed. They've been qualified to telecom applications, and we have a wide library of components to help solve those problems with onboard optics, whether it's a COBO module or a co-package optics module, everything that wraps around it. A lot of those things have been solved. Now we have some density issues that we need to look at with co-package optics because we're going to be going in vastly increased density, and we're also most likely moving towards single mode fibers and trying to solve those density issues. So to do that, what I did is I put together a demonstration card just for ourselves internally and to talk with customers about, okay, what does a co-package optics box look like? What might it look like? And what are the problems that we need to solve? So as I talked before, getting in and out of this card are things that we know. Getting around the card, we know a lot of that, but what we really have to look at is what is unique about co-package optics. The density is much higher. It's most likely single mode fiber. It might need polarization maintaining fibers. And more specifically, we need a new class of components and interconnect to attach to these, what I'll call the optical tiles that sit close to a chip that's packaged, in a thermal zone, high number of single mode fibers coming in and out, 500, 1,000 fibers. We have very limited edge density in terms of getting these fibers in and out. We would like to have a separable interface, and ultimately we're going to move away from a socket in the early stages and go to something that's probably reflow compatible. Those are big problems, big challenges to solve. And what the ecosystem needs to do is we need to look at how are we going to solve this interconnect issue, and what are the chiplets going to need, or the optical tiles in communicating on the substrate with an IC, right? So we're going to need these new interfaces that are very highly customized towards what another talk was talking about, an optical engine, which is maybe a pure photonic functionality, which is going to allow interfacing to chiplets or to the main die that's going to control the photonic aspects of it, right? So these are new things. On top of, we need, for some applications, we're going to need to get light into that chip. It's not going to generate its own onboard light. Some technologies can do that, but not all of them. and some discussion about, you know, PM fibers being able to do that, right? So there's lots of building blocks that need to be put in place here and solved in order to get into this optical package. Getting in and out of the box, getting around the box are things that we know, but getting in and out of this very tightly constrained area for photonics is what's